So I believe our first presentation is SolMATE, a linear algebra package for cloud-based machine learning via blockchain, with applications in IoT for Web 3.0 and quantum computing in the metaverse. Naveen is a fourth-year PhD student in chemical engineering at MIT. His research focuses on using machine learning to accelerate physical simulations of molecules. He is passionate about democratizing access to new technologies and has previously given informational talks at MIT on machine learning and financial markets. As lead developer of a matrix library for Ethereum, he hopes to give both newcomers and seasoned developers a fresh perspective on what could be done with Ethereum and the blockchain ecosystem. Naveen, please take it away.
Today, I'll be presenting about scientific computing on the blockchain. Specifically, I'll be presenting the paper that I wrote for SIGTBD, which is called SolMATE, a linear algebra package for cloud-based machine learning via blockchain with applications in IoT for Web 3.0 and quantum computing in the metaverse. In this presentation, I'll be explaining all aspects of this title. I have 5 minutes, right?
Yeah, 5 minutes.
Okay. So you might all be familiar with Bitcoin. Bitcoin became popular in 2006 because it's like money and it's digital. And then you might be familiar with Ethereum. Ethereum became popular a few years after because money. But one thing that distinguishes Ethereum from Bitcoin is the ability to do small computations every time you do a transaction. And because of that, you're able to have automated market makers on the Ethereum blockchain that will automatically process transactions and create markets for you to sell and trade coins. So hopefully I don't lose you here because there's words on the slide. But this is an infographic from BlockGeeks. I don't know what BlockGeeks is. This is the first thing that came up when I Googled how Ethereum works. So on Ethereum, you have 2 types of users. You have people and you have computers. So when you have people doing transactions, they're manually deciding what to buy and sell. When you have a computer doing transactions, you call that a smart contract. And a smart contract is able to execute code to decide on how to allocate trades. So some of you might have heard of Uniswap, which is a pretty famous protocol on Ethereum for making markets for trading coins within the Ethereum environment. This is what it looks like when you use Uniswap. You kind of have this portal where you can trade your Ethereum to US dollar coin or any other pair of transactions. Now, the thing is, in Ethereum, there's a language for coding up these smart contracts called Solidity. And it's a C-like language. There aren't many libraries for math on it, so you can only do simple algebraic operations. So the biggest market maker on the blockchain uses very simple formulas like add, multiply, divide, subtract to perform massive amounts of trades. So the question I ask myself is, can we do more? So what I wanted to do was be the first person to solve an eigenvalue on this system. So what I did is that I coded up a smart contract called SolMATE. I made the first vector library for Ethereum and the first matrix library for Ethereum, along with linear algebra libraries to supplement these. These can be found on GitHub. Pull requests are welcome. And here is the first ever smart contract that lets you solve for eigenvalues on the Ethereum virtual machine. So now we can solve systems of linear equations on the blockchain, but can we do more? Can we do machine learning? So in order to do machine learning, I did the big brain move, which is multiple linear regression and then call it machine learning. So this algorithm uses some just normal linear algebra methods to do machine learning. I posted this paper on LinkedIn, and then I got a bunch of offers to be CTOs of startups in the 100K to 300K range. So I'm not taking any like 300K jobs soon, but I might in a year, who knows? Okay, so then I asked myself, can we do more? Can we do quantum computing? So here you can see an example of a 2-qubit quantum computer. And it turns out that we can simulate this on the blockchain using SolMATE because all it is a 4x4 matrix multiplication. So I went ahead and implemented that and included that in my paper. So this concludes my talk. You can find the SolMATE package on GitHub. Pull requests are welcome. It's code in Solidity 8.11. And also, in my paper, I talk about applications for Internet of Things and the metaverse. So keep your eyes peeled for that. And together, I hope with SolMATe, we can build a better future.